Hey there, first period. So here is our last new stuff for the school year. Again, we're just kind of touching base a little tiny bit on chapter 5. So here is your essential question. And just so you know, I'm going to make this even easier than the book does on you, parts of it. So you might want to, instead of, if you've been watching the video and then going to the book for help, you might want to just watch the video a second time, because I think the book makes part of this way more complicated than it needs to be. And we don't like complicated, do we? So your essential question is, how can you determine if two events are dependent or independent? You might remember when we talked about X's and Y's being independent or dependent. Actually, for you guys, that might have been back still with Miss Mason. I'm not sure that was you and me or not. I don't remember. It was so long ago. Let's figure out what it means in the probability world. So, two events are independent events, okay, when one doesn't affect the other. So remember, an event is when we say we're going to pull a red marble out of the bag. That's an event, that we're going to pull a red marble instead of whatever other colors are in the bag. Okay, so it's independent if what you pull doesn't affect whatever's going to happen next. Okay, so there's this fancy mathematical way to figure out if things are independent or dependent, but I actually think that's more work than just reading the situation and thinking about it. Okay, so let's look at some examples. Make sure you write this stuff down, even this stuff, okay, because technically it's part of the chapter that we need to know. I just don't feel like it's the easiest way to do this. So here's an example, okay? So we actually we talked about this before, about the student taking a quiz and they randomly guess true or false on 4 questions, okay? So notice this says use a sample space to determine. That means it wants us to go back to when we wrote out, well, it could be incorrect or correct, correct, and then incorrect and all that stuff. Remember that? That was horrible and long and silly. I don't think we need to do that, okay? Let's just think about, does it matter what happens first with what happens next, okay? So say you're going along answering some questions on this quiz, right? And you get to 4 true or false questions. So if you answer true on the first one, does that have anything to do with what you answer on the second one? Well, some of you might say yes, because if you're just guessing, you're going to make some pattern and you're going to say true, false, but that's not what we're talking about here, okay? Does what you answer on the first question affect how you answer the second question? Well, no. They don't really have anything to do with each other. They might be the same kind of question, but that's not the point. In general, does it matter if you answer true on number 1? Is that going to have anything to do with your answer to number 2? Okay, and the answer would be no, so they're independent. They have nothing to do with each other. So let's keep going. By the way, let me just show you how the book wants you to do this, okay? So your probability of getting the first one right would be 1/2. It's 50-50 if you're going to get the first, if true or false is correct, right? So on the second one, it's also 50-50, okay? So if you multiply those two together, you get 1/4, okay? Well, if you I missed a step. So before we get to that 1/4, sorry, hold on. So before we multiply them. So if you figure out the probability based on that sample space, if you go back to that video from last week, of getting 1 and 2 correct, that is going to be 1/4, okay? So then if you multiply these two together, you get 1/4. If they're the same, then your events are independent, because it doesn't matter, okay? That's what the book wants you to do. I just want you to read the question and think about it, okay? You have to think, but you don't have to do any math. So hopefully that's an even trade there. So let's look at another one. Okay, so we've got a bag that has 6 pieces of paper numbered 1 through 6. Okay, so we've got this bag of numbers, right? And there's a 1, a 2, 3, 4, 5, and a 6 in there. Okay, so a student randomly, by the way, if we were in class, I would totally have a bag with pieces of paper and we'd see what happens. But anyway, a student randomly selects a piece of paper, replaces it, and then randomly selects another piece of paper. This right here, replaces it, those 2 words are huge. Okay, so say I take out a piece of paper, okay, or I've walked around the room and I had Sammy take a piece of paper out of the bag, okay, and he looks at it and he says, okay, I'm not telling you what it is, and then he puts it back, okay, so if he puts it back, replaces it, then there's the same number of pieces of paper in there as there were when Sammy picked the first time. So what that means is that the second person, okay, I walk a little bit further and I let Sam pick one, okay, then he is going to also be able to pick 1, 2, 3, 4, 5, or 6, okay, so therefore these are independent, okay, so it doesn't matter what Sammy picks first because he's going to put his number back. Now, work with me for a second. What if he didn't replace it? So what if Sammy first took out, well, say he took out the 5, right? And then I went on. Could somebody else take a 5 out of the bag? No, because it's not there, right? So those would be dependent because the second one depends on what Sammy took out the first time. Okay? We've got more examples, I think. I hope. Yes, we do. Okay? A group of 4 students includes 1 boy and 3 girls. Okay? So, in class, I would pull up 1 boy and 3 girls, and I'm going to select one of them to be the speaker and a different student to be the recorder. Okay? So, we've got a boy and 3 girls up there at front, right? Okay? So, say I pick one of them, and say I'm just going to pick the second one because 2 is my lucky number. So say I pick the second one of the that are standing up there, so that first girl to be a speaker, to be the speaker, okay? And then I have to pick somebody else to be the recorder. Well, it can't be the same person because she's already the speaker, right? So I would have to pick one of the other 3 people to be the speaker. So my second choice depends on who I picked the first one because I can't pick that one again. So they're dependent events because I have fewer to choose from the second time. I know this probably doesn't make a whole lot of sense, and it might be making your head hurt. I'm sorry. Go back and listen again. But it's really just about thinking, if you take one out, it's gonna change how many you have to choose from the second time, and so the second time is going to depend on what you picked the first time, and therefore it's a dependent event. Okay, independent would be when they have nothing to do with each other. Okay, this is basically the same question, so I'm going to move on. Okay, so again, the book has these fancy mathematical ways of finding these probabilities. Okay, and we're going to have to now figure out the probability of something happening. Okay, so this slide is really talking more about what is dependent. We've already talked about that. Okay, and when we have a dependent event, we have this thing called conditional probability. Okay, and this is the fancy way that we write it. What it means is that the probability of the second thing happening is conditional. It depends on the first thing. So we call it conditional probability because there's conditions involved. It's not a perfect situation because we've already taken something out of the hat or whatever. Okay, so let's see what all this means. Okay, so our probability. Okay, so I'm just going to say right up, you're multiplying things. Keep that in mind. You're multiplying things. And yes, fractions. Probability is all about fractions. Your chances are generally written in a fraction because your chances are 50-50 or 1/2. Your chances are 1/3 or 3/5. Okay, but it's not like fractions like you've had to deal with before. Okay, and all we're gonna do is multiply them. Okay, and that's the easiest thing you can do with fractions actually. So let's write this down in your notes, but we're gonna do some examples. Okay. So we have this spinner here, pretty spinner, 1 through 8. Okay, we want to find the probability that you get a 5 on your first spin and any number bigger than 3 on your second spin. Okay, so let's just talk about that first spin. So we're going to spin it and what's the probability that you're going to get a 5? Well, how many 5s are there? There's only one 5, right? So there's one favorable outcome. Okay, how many possible outcomes are there? 8, because there's 8 numbers. Okay, so remember, it's always favorable outcomes over possible outcomes. Favorable meaning whatever it tells you that you wanted to get. Possible meaning all of the different numbers or whatever you can get. Okay, so I'm actually going to erase that. Okay, and then it says on the second spin, you want to get a number greater than 3. Not 3, but greater than 3. So how many is that? 1, 2, 3, 4, 5 numbers are greater than 8, right? So that means there's 5 favorable outcomes. Okay? And how many possible outcomes? Well, there's still 8 possible outcomes because there's 8 numbers on the spinner. Okay? So this is your probability of the first thing, and this is your probability of the second thing. So how do we figure out the probability of it happening just like that? We get a 5 and then we get something higher than a 3. Well, multiply. 1/8. Actually, I'm going to do this in a different color. 1/8 times 5/8. Okay? Remember, when you multiply a fraction times a fraction, you just multiply across. So 1 times 5 is 5. 8 times 8 is 64. Okay? You can do one of two things, and if we were in class, I'd be picky, but I'm not going to be picky. You can either reduce the fraction and leave it as a fraction. In this case, you can't reduce that. Or you can actually put in your calculator 5 divided by 64 and get a decimal. I need at least 3 decimal places. Got it? So either one of these things would be acceptable for me. Most of the time when you're talking about probability, you're going to want it in a fraction though. Okay? Or a percentage, but let's not worry about that right now. Let's try another one. Okay, we're using the same spinner. I put it on here. Okay, find the probability that you get an even number on your first spin and then a number less than 3 on your second spin. Okay, well, what are our possible outcomes again? Well, 8, because it's the same spinner, right? So we have 8 possible outcomes no matter what we do. Okay, so an even number, how many even numbers are there? Well, 1, 2, 3, 4, right? 2, 4, 6, 8. So there's 4 out of 8 chances that you're going to get an even number. Okay, you could go ahead and reduce this to 1/2 if you want to, but you don't have to. You can use this to multiply later. Okay, and then and a number, and notice we're saying and a number less than 3. Well, that would be just these 2, right? 1 and 2. So that would be 2. Again, you can reduce that if you want to, but you don't have to. You could multiply these 2 numbers and then reduce at the end. It's up to you. Okay, I'll do it both ways. How's that? So 4/8 times 2/8 is going to be 16 over 64, which I happen to know reduces to 1 over 8. Or you could multiply 1/2 times 1/4 and get 1/8. Either way, you get the 1/8. Okay? If you really want it in decimals instead, because you want to do that extra step in your calculator, that would be 0.125. Okay? Hopefully that's it. Hopefully this is making sense to you. I think I have a couple more examples too. Okay, so a bag contains 20 $1 bills and 5 $100 bills. Okay, so how many total bills are in your bag is the first thing you need to think about. Well, there's 20 and 5, right? So that means you've got 25 bills. You have 25 possible outcomes. Your possible outcomes is always going to be the number of things in your bag, or the number of spots on your spinner, or dots on your, or sides on your die, or things like that, okay? So the probability that the first bill is 100 is what? Well, how many? There's 5 possible, right? $100 bills. So that means 5 out of 25. Again, reduce that. I think it's easier to reduce it here because for me, and probably for you, it's easier for me to know that 5 goes into both of those and it reduces to 1 over 5 than later when I have bigger numbers. Okay? So here's a big part of this question. So we randomly draw a bill from the bag, set it aside. Okay? So what that means is that we've now taken out that first bill. Okay? So how many bills are now in our bag? Well, 24, right? Because we took out and set it aside. We put it in our wallet or whatever. And now we only have 24 bills left. So the second time around, we have 24. Okay? So the first bill we're going to assume that this is true, that the first bill was 100, okay? So now, how many $100 bills do we have? Well, remember we took that one out and set it aside, so now we only have 4, okay? So now, let's reduce that. That's 1 over 6, okay? And now, we want to figure out that both of these things happened, right? So we're going to do 1/5 times 1/6 and get 1 over 30. And if you really want the decimal, that's 0.033. Again, give me at least 3 decimal places if you're giving me decimals. Okay? I need to see this and this in your work. If all you give me is this, you copied, you cheated, you did something that wasn't right. I need to see all of the work so I know how you got to that decimal or final fraction, please. Thank you. Okay, let's do one more. Okay, so we've got 9 women and 6 men are on a committee. Okay, before you even keep reading, think about how many possible outcomes that means you could have, which means on this committee there's 9 women, 6 men, 9 plus 6 is 15, so therefore your fractions are all going to be over 15. Okay, so we're going to find some committee members, right? Find the probability. Okay, so we're going to first figure out the chairperson. Okay, well, we want that chairperson to be a man. Okay, so I'm sorry, the chairperson is a man, right? So that means we've got 6 favorable outcomes over our 15. Okay, so that means that, if we reduce that, 3 goes into both of those, so 2/5, right? So again, if the chairperson is a man, that means we've got 6 favorable outcome choices, okay, out of our 15 total. Okay, so then we're going to pick the treasurer, right? Well, how many people do we have to pick from now? We still have 9 women, but how many men do we have left? We only have 5 left because we already picked one of them to be the chairperson, apparently. Okay, so that means we've got the 9 women out of the 14 people left. Okay, 9 over 14 doesn't reduce. Okay, so to find the probability of both things happening, we're going to do 2/5 times 9/14, which gives us 18 over 70. Okay, and this might be one that even if you do prefer fractions, you're going to give me a decimal because it's easier just to put in your calculator 18 divided by 70 and get 257%. I'm sorry. And get 0.257. Okay, but some of you might be able to look at that and figure out that 2 goes into both of those and get 9 over 35 as your fractional answer. Okay, again, don't forget, I need all of this stuff on your assignment, please. So on your assignment, most of it is figuring out if it's independent or dependent. Okay, and then there's just a few where you have to do this. Okay, and on Wednesday's videos, I'll go over one of each probably, okay, at least. Please put in the comments if you have any specific questions for me, and I will try to answer those for you in Zoom or in a video or something. Have a good day.